So good morning students, welcome back. My name is Aditya Nandwani and I am from MKS videos. So previous video में मैंने आपको बताया था कि यूक्लिड के एक्सियम्स और पोस्टुलेट्स जो कि क्या हैं, एक assumptions हैं मैथमेटिक्स में related to you can see here universal truth, right? So मैथमेटिक्स के अंदर यूक्लिड ने यूनिवर्सल ट्रुथ के ऊपर assumptions ली थी, ना कि प्रूफ. So यहाँ पे मैंने आपको कल एक्सियम्स एक्सप्लेन कर दिए थे. Now I'm going to explain postulate, but before that let me just recall what we have done till now. So अभी तक हमने क्या किया था, मैंने आपको प्रीवियसली बताया था कि जियोमेट्री का मीन्स होता है जियो मीन्स अर्थ एंड मेट्री मीन्स मीजर. सो हमें अर्थ की मेजरमेंट से रिलेटेड बात करनी थी, राइट? सो जो हमारे पुराने एंसेस्टर्स थे वो जियोमेट्री के बारे में काफी नॉलेज रखते थे और अर्थ की मेजरमेंट करना चाहते थे. लाइक आपको पता है कि इजिप्ट में बहुत सारे पिरामिड्स हैं. सो वो पिरामिड्स उन्होंने कैसे बनाए, क्योंकि उनको ज्योमेट्री की काफी अच्छी नॉलेज थी, राइट? तो अगर मैं यहाँ पे पढ़ना स्टार्ट करता हूँ तो यहाँ पे लिखा है ब्रांच ऑफ मैथमेटिक्स वाज स्टडीड इन वेरियस फॉर्म्स इन एवरी एंशिएंट सिविलाइजेशन. हमारे से पहले वाली सभी एंशिएंट सिविलाइजेशन में जो मैथमेटिक्स की ब्रांच को स्टडी करते थे उनकी वेरियस फॉर्म्स में स्टडी करते थे, यानी कि हर सिविलाइजेशन का अलग मेथड था मैथमेटिक्स से रिलेटेड. सो इसी तरीके से अगर मैं आपको बताऊं कि नॉलेज ऑफ ज्योमेट्री वाज यूज्ड बाय देम फॉर कंप्यूटिंग वॉल्यूम्स ऑफ ग्रेनरीज, कैनाल्स एंड पिरामिड्स. सो हमारे एंसेस्टर्स ने क्या किया था, ज्योमेट्री की हेल्प से वेरियस फॉर्म से उन्होंने वॉल्यूम को मेजर करना सीखा, कैनाल्स को मेजर करना सीखा और पिरामिड्स को भी मेजर करना सीखा. सो उनके पास काफी अच्छी नॉलेज थी ज्योमेट्री की, जिसको उसने यूज किया मेजर करने के लिए वॉल्यूम्स को ऑफ ग्रेनरीज, कैनाल्स एंड पिरामिड्स. अब इसके बाद मैंने आपको बताया था कि जो एक मैथमेटिशियन था, ग्रीक मैथमेटिशियन whose name was Thales, he actually given a theory about, you can see there's a circle and diameter of a circle actually divide the circle in two half equal parts. So who was that who given this theory? There was Thales. So there was a Greek mathematician who given that the diameter of a circle actually divides the circle into two equal parts. Now Thales का एक apprentice था, मीन्स स्टूडेंट था, जिसका नेम था यूक्लिड, जिसके बारे में हम डिस्कस कर रहे हैं. तो यूक्लिड ने क्या दिया था, एक्सियम और पोस्टुलेट्स दिए थे. अब आपको मैं पहले बता चुका हूं कि एक्सियम और पोस्टुलेट्स क्या हैं, जो कि assumptions ली थी उसने, नॉट अ एक्चुअल प्रूफ. देयर वाज ओनली assumptions इन मैथमेटिक्स रिलेटेड टू यूनिवर्सल ट्रुथ, लाइक सन राइजेस इन द ईस्ट. सो ये अर्थ के किसी भी पार्ट में हम जाएंगे तो सन कहां पे राइज होगा, ईस्ट में ही होगा. सो दैट वाज यूनिवर्सल ट्रुथ. सो जो यूक्लिड था उसने अपनी एक्सियम और पोस्टुलेट्स दिए थे, मींस उसने अपनी assumptions दी थी अबाउट यूनिवर्सल ट्रुथ, नॉट एक्चुअल प्रूफ. अगर हम एक्चुअल प्रूफ की बात करते हैं तो थ्योरम्स जो होती हैं हमारे पास मैथमेटिक्स में वो एक्चुअल प्रूफ के साथ होती हैं, बट assumptions हैव नो प्रूफ. So Euclid has given axiom and postulate which are not the proof of that, just an assumption of universal truth. So हम कल axioms की बात कर चुके थे, अब हम next बढ़ते हैं postulates की तरफ. So सबसे पहला जो postulate Euclid ने दिया था, that is like a straight line may be drawn from any one point to any other point. So यहाँ पे इस पोस्टुलेट में उससे कहने का ये मतलब है कि अगर मैं यहाँ पे, जैसे कि आप देख सकते हैं मैंने दो पॉइंट्स लिए हैं P और Q. सो अगर मैं इस P पॉइंट से एक लाइन ड्रॉ करूं लाइक दिस, सो दैट ये लाइन Q में से भी पास हो, राइट? सो आप देख सकते हैं कि सिर्फ ओनली एंड ओनली वन लाइन कैन पास थ्रू एट अ टाइम फ्रॉम टू पॉइंट्स साइमल्टेनियसली. मतलब एक साथ दो पॉइंट्स में से सिर्फ एक सिंगल लाइन ही पास आउट होती है. जैसे कि मैं आपको और इलैबोरेटरी बताता हूं, अगर मैं सिर्फ पॉइंट P में से एक लाइन पास आउट करूं लाइक दिस, सो दिस लाइन कैन नॉट पास फ्रॉम Q. सो देयर इज ओनली वन लाइन विच कैन साइमल्टेनियसली पास फ्रॉम P एज वेल एज Q. बट जो एक सिंगल पॉइंट में से बहुत सारी लाइंस पास आउट कर सकती हैं. सो देयर आर इनफाइनाइटली मैनी लाइंस passing through a single point, but there is only one line which can pass through two points simultaneously. So आप देख सकते हैं P और Q में से सिर्फ एक सिंगल लाइन ही पास आउट हो सकती है. there is only one and only one line which can pass through 2 points simultaneously. That's what the postulate first is saying, right? Getting my point? So it says a straight line may be drawn from any one point, you can see here from P to any other point Q. So there's only one line, remember this one point, right? So there can be many lines which can pass from a single point, but there's only one line passing from 2 points simultaneously. That's what the Euclid's first postulate tells us. So students, बढ़ते हैं second postulate की तरफ. So second postulate says that a terminated line can be produced indefinitely. सबसे पहले अब आपको समझना पड़ेगा कि ये वर्ड terminated line क्या होता है. जो आज के टाइम में हम terminated line को क्या बोलते हैं? Line segment. So let me just write it down here that line segment was called by Euclid at that time terminated line. लाइन सेगमेंट आप सबको पता ही है कि क्या होती है. इट इज अ पार्ट ऑफ अ लाइन, दैट मीन्स इट हैज टू एंड पॉइंट्स ए एंड बी. सो लाइन सेगमेंट इज एक्चुअली अ पार्ट ऑफ अ लाइन, नॉट अ कंप्लीट लाइन. इट्स जस्ट अ पार्ट ऑफ अ लाइन. सो इट कैन बी एक्सटेंडेड इन आइदर साइड्स, लाइक आई कैन एक्सटेंड इट ऑन द साइड ऑफ बी as well as on the side of A. So a line segment is just a part of a line. It can be extended on both of the sides from the endpoints. You can see I can extend it in the left side of A and also I can extend it in the right side of B. So this is a line segment which can be extended in both sides. So this is what postulate second says. So at that moment this line segment was called terminated line. So there's no difference in the term line segment and terminated line. So they are same. So a terminated line can be extended in either sides indefinitely. That means you can extend it to infinite. So we don't know that how much length of the line is, so it can be infinite. So a line segment can be extended infinitely or indefinitely on either sides. That's what the Euclid's postulate second says. So students, moving on to postulate number third, and it says a circle can be drawn with any center and any radius. सब आप सब जानते हैं कि circle क्या होता है? It's a spherical structure and we can draw any circle from any center and of any radius. Suppose there's a point O and I have to draw a circle, then I will open my compass and just simply draw a circle of any radius. Are you getting my point? So this is what this postulate third is saying, that a circle can be drawn with any center and any radius. So you can draw a circle of say 3 centimeter, you can also draw a circle of 4 centimeter, 5, so on. So you can draw a circle of any center and of any radius. That's what the postulate third of Euclid is saying. Right? So that's all. So students, moving on to postulate number fourth, and it says all right angles are equal to one another. Now you all know about the right angle, that means 90 degrees. Let me just draw a square here for you. Now you can see, you all know that a square has 4 equal sides and all the 4 angles of a square are at right angle. That means 90 degrees. So you can see here there are 4 right angles. Right angles are formed when the lines are actually perpendicular to each other. That means at 90 degree. And in the case of square, as you can see, all the sides are at 90 degrees. All the adjacent sides of a square are at 90 degrees. As you can see here, let me just name this square as ABCD. Now you can see clearly that this side AB is actually perpendicular to BC. So we can write it down as AB is perpendicular to BC. This sign is of perpendicular. Remember, so the perpendicular lines have a 90 degree angle in between. Right? So this postulate is actually saying that all right angles are equal to one another. Now you can see this right angle is equal to this is also equal to this and this. So all the right angles are equal as they have the value 90 degrees. So in the case of square, all the right angles are equal to one another. So that's what the postulate 4 refers to. So बढ़ते हैं student postulate number 5 की तरफ. and it says like a straight line falling on two straight lines. So let me first explain you step by step. So यहाँ पे मैंने दो straight lines लिए हैं AB and CD, and there's another straight line PQ which is intersecting both the lines AB and CD. That means the line PQ is falling on two straight lines. That is what written here. So a straight line falling on two straight lines, you can see here, makes the interior angles. So let me just first explain you what are interior angles. Interior, as the name says, at inside. So आप देख सकते हैं यहाँ पे मैंने रेफर किया है 1 and 2 two interior angles को, which is lying on the same side of this line PQ. This line PQ actually is also known as transversal. Now let me tell you what a transversal line is. It is a line which is falling on other two straight lines and intersecting them at respective points. So आप देख सकते हैं कि ये जो लाइन PQ है वो लाइन AB और CD को इन 2 points पे intersect कर रही है. That's why it is called as transversal. That means it is cutting the straight lines at two respective points. अब आप देख सकते हैं कि इस transversal line के same side पे इन साइड में दो एंगल्स बन रहे हैं जिसको मैंने 1 और 2 मार्क किया है. यहाँ पे एक्चुअल में जब एक ट्रांसवर्सल कट करती है टू स्ट्रेट लाइंस को, तो टोटल नंबर ऑफ एंगल्स फॉर्म्ड आर 4. सो यू कैन सी दे आर ऑन द राइट हैंड साइड and 1 and 2 are on the left hand side. So on the same side of transversal there are 1 and 2 as well as 3 and 4. They are on the right hand side, these are on the left hand side. Now the thing is, मैं बात करता हूं कि अगर ये दोनों लाइंस, अब आप देख सकते हैं AB और CD पैरेलल नहीं है एक दूसरे के. That means the angle formed interior on the same side of each angle is going to be less than 90 degrees. अब आप देख सकते हैं ये दोनों एंगल 90 डिग्रीज के लेस होंगे. समझ में आ रही है बात? सो अगर मैं इन दोनों एंगल्स को ऐड करूंगा विच आर ऑलरेडी लेस देन 90, सो देयर सम इज गोइंग टू बी लेस देन twice of 90. That means 180, because both the angles are less than 90. So their sum is also going to be less than 180. That means two right angles, right? So this is what the postulate says. If the interior angles on the same side formed by a transversal is less than two right angles, or you can say 180, then if I just simply extend these lines from this point, like you can see at that side where the sum of angles is less than 180, then they are going to intersect at one point if they are extended on that side. This is what it's saying, that the point, the side where the sum of interior angles is less than two right angles, or you can say 180, then extending both the lines on that side, both the lines will intersect at a point. That means they are not going to be parallel lines. They are going to intersect at one point. So if I just read it here, that a straight line falling on two straight lines makes the interior angles on the same side of it taken together. That means we are going to add the angles less than two right angles. You can see the sum of both the angles is less than two right angles. Two right angles means 90 plus 90, 180. So it is less than 180, or you can say two right angles. So then you can see if produced indefinitely, both the lines are going to meet each other, or you can say intersect each other. So they are going to intersect or meet at a point on that side where the sum of angles is less than two right angles of 180. So this is what this postulate says, that lines are intersecting or parallel can be acquired by getting the sum of interior angles on the same side, whether it is less than 180 or equal to 180. If they are equal to 180, that means lines are parallel. But if the sum is less than 180, then the lines are going to intersect each other on that side. That's all. So students, that was all about the base of this chapter based on Euclid's axiom and postulates. I have defined you the axioms. There were 7 axioms, remember, and there were 5 postulates. So these were all assumptions made by Euclid based on universal truths. So I have told you about the axiom and postulates. Now let's just move on to exercise here. So I'm going to discuss exercise 5.1. So let me just move on to it. The first question says, which of the following statements are true and which are false? Give reason for your answers. So I have to justify the statements whether they are true or false and give a reason for that, right? So first part here is only one line can pass through a single point. Now remember, in the previous section I have told you that there are infinite many lines which can pass through a single point. So let me again draw a single point here. Now I've told you there are infinitely, let me just denote it with P. So there are infinitely many lines which can simultaneously pass through a single point. Remember, so there are infinitely many lines. You can say infinitely many lines can pass through a single point, as you can see here. So this statement, the first statement, that is only one line can pass through a single point, is clearly false. It is visible to you that infinitely many lines can pass through a single point. So this statement is false, and that is the reason, right? That's all. So students, moving on to second part here, and it says there are infinitely many number of lines which pass through two distinct points. As I have told you earlierly, if I just simply take two different points as I have taken earlier, like P and Q. So remember, there is only one and only one line which can pass simultaneously through two distinct points, right? So individually from a single point there can be infinitely many lines, but from two distinct points there can be infinitely, there's only one line which can pass through two separate points, right? So there's only one and only one line which can pass through two distinct points. So this statement is clearly false, which says infinitely many lines can pass through two distinct points. So it is clearly false, as one and only one line can pass through two distinct points. Got it? So that's all. So students, moving on to third one here, and it says a terminated line can be produced indefinitely on both the sides. Remember the postulate second, which says a terminated line can be produced in either sides indefinitely. So this statement is the postulate number second itself, which says that a terminated line, you all know a terminated line means a line segment, which was called at that moment by Euclid as terminated line. So a terminated line is actually a line segment nowadays which can be actually indefinitely extended on either sides. Remember, so this is the postulate number second. So refer to postulate, let me just write it clear, the postulate number second. So it is true. So just to write refers to postulate number second, that's why the statement is clearly true. So students, moving on to fourth part here, and it says if two circles are equal, then their radii are equal. Radii means radius of two circles. In short form, two circles radius is called radii. Now let me just check out whether if two circles are equal, then the radius is also equal or not. Let me just draw a circle here with center O. Now you can see that this circle occupies this region. That means this is the boundary of the circle, or you know, this is the circumference of a circle, right? So with center O, this is one circle. Let me just draw another circle which is equal to it. Let me just superimpose another circle over this circle's region. Now let me just take the another circle center as O dash. Now you can see both the center are superimposing. That means they are lying on each other, and both the circles are equally occupying the same area. That means the circle which I have superimposed on the previous circle clearly matches the boundary of the previous circle as well as the center. So when we just simply superimpose, so if I have to write the solution here, so I am going to write, if we superimpose just one over other, so superimpose a circle with another circle, occupying same area and, or you can say, boundaries and center, then you can say, hence radius of both circles are equal. So this statement is clearly true, right? So this is the reason which is beneath this statement. So if we just take two circles of equal, then both the radius are going to be equal. That's all. So students, moving on to the fifth and last part, which says that in figure 5.9, if AB is equal to PQ and PQ is equal to XY, then AB is equal to XY. So in this figure, there are three line segments which are given to us, namely AB, PQ and XY. Also it is given to us that this line segment AB is equal to PQ and further this PQ is equal to XY. Now remember the Euclid's axiom first, which says things which are equal to the same thing are equal to one another. Now here it is clear that AB is also equal to PQ, as well XY is also equal to PQ. You can see here it is given to us that AB is equal to PQ as well as XY equal to PQ. That means both the line segment are equal to the same line segment. Then both are going to be equal to one another. If I just simply give first and second, then from first and second, it is clear that both AB and XY are equal to PQ. That means AB is going to be equal to XY. So this statement is true and refers to axiom number first. So it's referred to Euclid's axiom number first. That's all. So students, that was all about question number first. Now moving on to question number second, which says that give a definition of each of the following terms given here. So these are the 5 terms which are given to us and we have to give a definition to it. Further, are there other terms that need to be defined first? So he is asking that is there any other terms which should be told before just giving the definition of these 5 terms, right? Now further, and how might you define them? So there are many terms which should be defined first, after then we will go on to these 5 terms. So what are the other terms which we first know before giving the definition to this? And that are, first is the point, line, plane, ray, angle, circle and quadrilateral. So these are the 1, 2, 3, 4, 5, 6, 7 points or terms which you can say we should know first. So let me just move on to the first one, which says point. Now what is a point? As I have earlier told you, a point is simply dimensionless structure. It has no dimension, it just got a position there. So let me first give a definition to a point. So point is a small dot. Let me just simply take a plain paper and I will simply draw a dot there. So a point is a small dot made by a sharp pencil on a sheet of paper, right? Which gives an idea about a point. So this is how only we can define a point. It is not possible to physically explain what a point is because it is a dimensionless structure. So let me just write, a point has no dimensions, it has only position there. right? So this is the definition of point which we first know before defining all these 5 terms. So students, moving on to second term, that is line here, it can be defined as a straight crease obtained by folding a paper. Right? If I just simply fold a paper in half and then open it, then we will obtain a straight crease, which can be an example of a line. Or you can also just pull a straight string at its 2 ends. If I just simply stretch a string from both the ends, that will also form a line. It can also be an example of a line. Now also, if the edge of a ruler, or you can say a scale, so the side of a scale is also a line. So these are the examples of a geometrical line. So clearly we can just briefly say a line is a straight structure and it should be extended indefinitely in both the directions. Remember, I have taken a line segment like AB, which is a part of a line, and if I just extended it both the sides, it is called completely a line. So line should be extended in both the direction indefinitely. So line is a straight structure, or you can say a line is straight and it should be extended indefinitely in both the directions. Now moving on to the third term which we should know, that is plane. So if I just take a plane definition, so plane is a surface of a smooth wall or sheet of paper. So a smooth wall, or you can take a sheet of paper, both are an example of a plane. So simple, a floor can be also taken as an example of a plane. So a smooth wall or a sheet of paper is clear example of plane. So students, moving on to the next term, that is E, that is angle. So let me first define you what is angle. Now let me again explain it to you with the help of 2 rays. Now observe, just imagine there's a point O which is a light source. Now this is an end point from which light is emerging. So let me just take one ray named OA, right? As I have told you, a ray is which has got one end point and extended in one direction and got another point on it. So this OA is actually a ray. Now let me just take another ray with a similar end point from O. The ray is emerging another ray. Let me just name it OB. So you can see this is actually a structure of 2 rays emerging from one same end point, and that is O. Now you can see clearly both the rays are emerging from single end point, and that will form an angle here. So you can name this angle as theta or any angle which can be measured in degrees, right? So an angle is actually a union of 2 non-collinear rays. Now what is non-collinear rays? Let me first explain you what a collinear word mean. Now collinear means, if I just simply take 3 points in a line which actually lies in the same line, so these 3 points are going to be collinear, which lies in the same line. But if I just simply take 3 points at a different places, then that is not going to be linear. That will be called as non-collinear. That is the case with this same structure. You can see O, A and B, all the 3 points are not lying on the same line. They are at different points. So this is a structure of non-collinear rays. So O and A are in the same line, but O and B are on a different same line. Remembering, that means O, A and B simultaneously are not on the same line. So these 2 rays are actually called non-collinear rays. So angle is a union of 2 non-collinear rays with a common initial point, that is called O, right? So this is what an angle is. So moving on to the next term, that is circle here. Now a circle is a set of all points in a plane whose distance from fixed point is constant. Let me first just take a fixed point here with name O and draw a circle of some radius like this. Now remember, this is the circumference of the circle, and if I just simply take a numerous number of points on this circle, infinite number of points on the circumference of circle. So all these points lie in a plane and on the circumference of circle. Now it is visible that the distance of all the points from the center is going to be fixed. You can see all the distance are going to be equal. So this is actually the radius of circle, right? So the distance of the points lying on the circumference of circle in a plane is from the center of the circle is going to be same. So this is how a circle is formed, right? So if I just simply read this, so these points on the circumference is a set of all points, right? So set of all points in a plane whose distance, actually the distance of all these points from the center is fixed, or you can say constant. So this is how a circle is formed. So this is the definition of the circle. So students, moving on to the last term here, that is quadrilaterals. Then we will move on to the respective terms given in the questions, right? So what a quadrilateral is a closed figure made of 4 line segments, right? So it can be a square, it can be a rectangle, it can be a parallelogram. So any structure which has got 4 sides is actually a quadrilateral. Like square is also a quadrilateral because it has got 4 sides. And if I take a rectangle, it has also got 4 sides, so it is also a quadrilateral. Let me just write rectangle. So any structure, parallelogram is also a quadrilateral. You can say rhombus is also a quadrilateral. So any structure which has got 4 sides is a quadrilateral. That's all. So students, now I have explained you all the terms which we first know before explaining these definitions, right? So we have done all the terms which we should first know. Now moving on to this first term which was asked in the question here, that is parallel lines. So what are parallel lines? Like these two structures, like AB and CD. These two lines are actually parallel lines. Now what is a parallel lines? Lines are said to be parallel. This is a sign of parallel, right? That means parallel line structure. So this is a sign of parallel. We can also write at the place of parallel like this. Now lines are said to be parallel if they are non-intersecting. Like intersecting lines are like these, which intersect at a common point, right? So here these two lines are not intersecting. So first condition of parallel lines is that they should be non-intersecting. They should not intersect at any point. The distance between these two lines is same at every point. They are like the structures of a train path, right? So you have seen a train path. These two lines of a train are actually parallel lines. So they not intersect each other. The distance between them is going to be same at any point, right? So the second thing is they are coplanar, that they lie on a same plane. So anything which are lying on a same plane is called coplanar. So two properties here for parallel lines, that they are non-intersecting, and second one is they are coplanar. So these are parallel lines. So students, moving on to the second term, which is perpendicular lines. Now what are perpendicular lines? Lines which form a right angle and intersect at a common point. Now you can see here there are two lines AB and CD, both are intersecting at a common point. Now the thing is, both the lines intersect at a common point and also they form a right angle, that is 90 degrees, right? So lines which form a right angle and intersect at a common point are called intersecting lines. So students, moving on to the next term, that is line segment. Now what is line segment? Line segment is a part of a line. Now you can see I have drawn a structure here which has got direction in both the directions. So this is actually a line. Now if I just simply take this area, that means two endpoints A and B. So this is a part of a line. That means a part of a line is called a line segment which has got two endpoints, namely A and B. So if I just read it, the part of a line which with two endpoints named A and B is called a line segment. That's all. So students, moving on to the last but not the least, that is radius. Now radius, as you all know, I have drawn a previous circle where I told you that the distance from the center to the point on circumference of a circle, like here OA, refers to as radius of circle. So any point lying on the circumference of a circle and having the distance from the center to that is called the radius of the circle. So a circle has got a equal radius at any point, right? So this is the radius of the circle, right? And the next and the last one is, that is square. Now a square is actually which is having four sides, that means a quadrilateral also. So a quadrilateral with all four sides equal, remember? So all the sides of a square, you can see the line here, this shows that all the four sides here are equal. And also one more property here, that all the four angles are of 90 degree, right? That means all the adjacent sides of a square intersect each other at 90 degree. That means a square is a quadrilateral which has got four equal sides and all the angles are right angles. That's all.